In this video, we're going to do several examples in which we will sketch the graph of the given polar equation and then find its corresponding xy equation. So the first example is going to give us r is equal to 4. So as you can see, r is equal to 4 means that the radius will be constant. The distance from the origin will be always 4 for any angle theta. Okay, so this probably gives you the suspicion that this will be a circle, and you're absolutely right, because if the radius is always the same no matter what the angle is, it's going to be a circle centered at the origin, right? Because the distance is the radius. Okay, so we can just put a circle. Okay, something like that. Okay, it's not going to be exactly right, but think of it as the distance 4. Okay, the distance 4. Can use another color. The distance 4. Okay, so now in order for it to be correct, you must get the equation x squared plus y squared is equal to 4. Okay, because that's the equation of the circle centered at the origin with radius I'm sorry, not 4, 16, with radius 4, right? But since it's squared in the equation, you get 16, right? But to get there, notice that you can do r squared is equal to x squared plus y squared, right? That's the substitution, the polar substitution that you should do. The r is equal to 4, right? So you will have 4 squared is equal to r squared, x squared plus y squared, right? So in the end, you get x squared plus y squared is equal to 16. Bingo, right? Same equation as you thought. Okay, now let's do the next example. Well, I should write the coordinate of this, let's say, so that you know it's 4. The radius is 4. R is equal to, well, how about r is equal to 4, right? R is equal to 4, right? I'm not going to write x squared plus y squared is equal to 16, right? This is the polar graph and this is the polar equation. Okay, so now let's do another example. So the second example only gives us the angle. Theta is equal to pi over 6. Okay, so from your intuition, you might say, well, the angle theta is always the same. So we can have any radius of any length, and the angle will always be pi over 6. And yet you would be absolutely correct, right? So you would draw something like this, pi over 6 through the origin. Okay, something like that. That's a line that never ends, right? So you will have a linear equation derived from this. Okay, but first, let's label this angle pi over 6. Theta is equal to pi over 6, right? That's the polar representation of this line. Theta is equal to pi over 6, and that goes for any radius. Okay, so now let's derive it. So how would you derive the xy equation? To derive it, you would take the tangent on both sides, right? Tangent of theta is equal to tangent of pi over 6, right? Notice that you can do that. So tangent of pi over 6 is equal to sine of pi over 6 divided by cosine of pi over 6. Sine of pi over 6 is 1/2. Cosine of pi over 6 is radical 3 over 2. Right, so that gives you 1 over radical 3. Now notice that in the famous substitution, tangent of theta is equal to y over x. Right, so we can now set 1 over radical 3 equal to y over x. So what do you get? You simply multiply both sides by x. Okay, and as a result, you will get y is equal to 1 over radical 3x. That's your corresponding xy equation of matching this graph on the right. Okay, so let me circle that for you like this. This is like that. Okay, So now let's do the third example. It's going to be a little more complicated. So now we're going to have r is equal to cosine theta. Okay, notice that the radius is not constant, right? The distance from the origin will not be constant. It will depend on angle theta. Okay, so let's draw the xy plane, or rather the polar graph, but I'm just going to label x and y. Okay, so now think of this. Plot the write the angle measures, the theta measures, right? Try 0, try pi over 2, try pi, and then finally try, well, 3 pi over 2, and then finally 2 pi. Try that and see what you get. Okay, so in those cases, cosine of 0 is going to be 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. And those are the r values. Keep in mind, right? These are the r values because r depends on theta, right? So we're checking theta, the input, and the output is the r, the radius, the distance from the origin. Now cosine of 3 pi over 2 is going to be 0 once again, and then finally cosine of 2 pi is going to be the original as cosine of 0, that's 1. Okay, so now let's plot those distances from the origin. Okay, let's see. So the radius, now keep in mind that when you have a radius only given the r, you're talking about a circle, but you're not sure how to draw that circle yet, right? The circle will be determined by the theta angle, right? So here, you might think, wait a second, if cosine of 0 is 1 and cosine of 2 pi is 1, then I'm talking about the starting point not being the origin from which the distance is measured, but rather, well, actually, yeah. So we're talking about the radius at 0 angle being 1, so we can label it. Let's label with 1 tick here. Okay, so the radius is 1 for cosine of 0. Then at pi over 2, where the y-axis is, the positive y values, the cosine of pi over 2 is 0. Okay? So we're talking about this point. We're talking about the origin, right? We're not moving the radius anywhere. The radius is 0. We're at the origin. The distance is 0 from the origin. Then cosine of pi is negative 1. Right? So technically you might say, oh, well, it should be here. No. Here's where it gets tricky. Notice that the cosine of pi is the r value. That's the radius, right? Because the radius is dependent on the theta angle. Since the radius is negative, we go in the opposite direction. We do not plot it at the negative 1 here, the distance. We're rather going in the opposite direction and also considering the absolute value of that, right? So we're going here to this point again, to this initial point. Right? And then finally, cosine of 3 pi over 2 is 0. That doesn't change anything. We're back to the origin again, right? Because the distance is 0, like in the cosine of pi over 2. So the radius is 0 there. And now finally, cosine of 2 pi is 1. So we're back at that initial point. So basically, if you suspected that this is where your circle points are, points on the circle, that is, these 2 points, you would be correct. Okay, so we could draw the circle through those 2 points, trying to draw it. Let's see how we can do it. Yeah. Something. Not really. Yeah, this would be probably a little better. Yeah. Maybe, yeah, something, yeah, something like that. Okay, something like this. Passes through 1, 0. Right, so we can label this as r is equal to cosine of 0, cosine of theta. So now you might say, but wait a second, how do we find the representation, the xy equation? Well, first of all, notice that if the radius is 1 here, if the radius is 1/2, because the diameter is 1, right, from the origin to the point 1, comma 0, that means the radius is 1/2. If the radius is 1/2, and based on the diameter where it is at the endpoints 0, comma 0 and 1, comma 0, it means the center must be 1/2, comma 0. So you might suspect the equation is probably x minus 1/2 squared plus y squared is equal to the radius squared. What is the radius? 1/2, right? So it should be this. But we need to get there, right? We need to derive this equation. So we're going to use this equation, the polar equation. R is equal to cosine of theta. So now we can write the original. R cosine theta is equal, R is equal to cosine theta. Notice that you can multiply both sides by R. Okay, so multiplied by R, you will get R squared is equal to R cosine theta. Now guess what? Remember the famous substitution R squared is equal to x squared plus y squared? Right, so we're going to use sub R squared is equal to x squared plus y squared. And also R cosine theta, we're going to sub it as x, right? Because remember how in the first example, well, rather in the previous video, we knew that the polar representation of x and y would be R cosine theta and R sine theta respectively, right? So now we can use that and we can now work it out. So x squared plus y squared is equal to x. Okay, so this is your equation. And if you want to confirm that it equals to the equation of the circle, you can complete the square. Okay, you can complete the square as this. X squared minus x plus y squared is equal to 0, which leads you to completing the square x squared minus x, and you're going to square 1/2 of this coefficient, of the coefficient of x, right? So negative 1/2 squared is going to be positive 1 over 4. Subtract that 1 over 4 because it wasn't there before, right? Plus y squared is equal to 0. So in the end you get x minus 1/2, right? Square that and you will get these three terms when you expand this, right? And the middle term, so factors of 1, 4 that sum up to negative 1, right? It's going to be negative 1/2 and negative 1/2. These are the factors. And then plus y squared is equal to, what are you going to do? This negative 1/4 can be added on both sides and it turns to 1/4 on the right side. And that's exactly, guys, look what's going on. That's exactly the equation that you've suspected before. See? That's the same equation. So you've actually derived it. Okay, now final example is going to be similar to this. It's going to be R is equal to 3 sine theta. Now notice that compared to the previous example, the magnitude here is 3, whereas before there was just 1. Right? So you're definitely talking about the diameter being 3. Right? It makes sense because here the diameter was 1 and that's why it matched the coefficient 1. Here the diameter of the circle will be 3. Right? So I'm not going to write these values because I'm running out of space. But I'm going to put the graph here. And let's test the theta values. Okay, so let's see. So we're going to need 1, 2, 3, probably many ticks. 2, 3, 1, 2, 3, 1, 2, 3, just in case. Okay, so the distance from the origin at theta 0 is 0, right? Because sine of 0 is 0 times 3 is 0. So we are at the origin. We started the origin. Sine of pi over 2, right? Going to pi over 2 now. Sine of pi over 2 is 1. 1 times 3 is 3. Great. So we're going up here for the third point, 0, 3. Now, sine of pi is 0, so we're back here again at the origin. Sine of 3 pi over 2 is negative 1. But keep in mind, we can't go here because the radius is going to be negative 3. It's negative. So since it's negative, we have to go in the opposite direction. So we must be here again on the top. And then finally, sine of 2 pi is 0, so we're back at the origin. So our suspicions were correct. It is the circle with diameter 3, as we suspected, using this number. Right? So, yeah, something... Maybe I can draw it better. No. I think I should draw it closer. Yeah, like that. Okay. Not the best picture. Well, maybe. Yeah, that's better. Okay, so that's the equation of that is, well, let me write that. So that's r is equal to 3 sine theta. So now you can tell visually what the equation may be, the xy equation. Visually, I can say, let me separate that from the last example. So visually, I can say that this is centered at the point 1.5, right? Because the radius is exactly 1/2 of the diameter, right? The diameter is 3, so the radius is 1.5. So we're talking about 3 over 2, right? 3 divided by 2 is 1.5. So the equation, and the center is 1.5, right? So the center has coordinates 0, 3 over 2, right? So it's going to be, so I suspect that the equation is going to be x squared plus y y minus 3 over 2, right? Because the center, the y is moved, right? And the center for the x remains the same. It's at x is equal to 0, right? So that's why there's nothing subtracted or added there. So minus 3, 2 squared is equal to r squared. The radius is 3 over 2, right? So it should be 9 over 4. So that's my suspicion. That's the equation. Let's derive it. Again, multiplying both sides by r, we will get r times r is equal to 3 sine theta times r, right? Both sides must be multiplied. So now we're going to get r squared is equal to 3r sine theta. Now we're going to use substitutions. R squared is going to be x squared plus y squared, and r sine theta is going to be y, right? Remember in the previous example, our cosine theta was x, this guy here, but our sine theta is y. That's the rectangular representation of the point of the polar coordinate, right? So now we're going to substitute these guys into the equation here. So we're going to get x squared plus y squared is equal to y. Subtracting y on both sides, we're going to get x squared plus y squared minus y is equal to 0. So this is your equation. But now let's transform this into the equation that we suspected was true. Right? The equation of the circle centered at the point 0, 3 over 2 with radius 3 over 2. Let's change this. So now completing the square, we're going to get x squared plus y squared minus y, and taking 1/2 of this coefficient and then squaring it will give you, what is it going to give you? It's going to give you plus 1 over 4 minus oh, wait a second. I made an algebraic mistake. I forgot that, yeah, I just put y in here. There should be 3y, right? Because 3 multiplies the r sine theta, right? That was my mistake. Let me correct that really quick. So that should be 3y. Okay, so that's 3y, right? 3y. So then this guy should be minus 3y instead. Okay, so minus 3y is equal to 0. Then this guy is minus 3y as well, and it will definitely affect this coefficient after that. I mean this constant, sorry. So minus 3y, and then plus one half of this coefficient. Negative 3 over 2 squared is 9/4, right? Plus 9/4 minus 9/4 is equal to 0. So in the end, we're getting this, right? We're getting x squared plus, now let's put these three terms in parentheses. So it's going to be y minus 3/2, right? And then square that, we'll get three terms if we expand this. These three terms. And then negative 9/4 can be added on both sides, and it will be 9/4 positive on the right side. And that's exactly, guys, what we suspected. There we go. So this is the equation of this is the rectangular representation of the equation that was given as polar equation r is equal to 3 sine theta. Thank you so much for watching. I hope this was enjoyable to you. Please subscribe if you want, and I'll see you in my next video.